Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗚𝗟𝗟𝗟 and today we're playing filtered-shellcode from PicoCTF, another binary exploitation challenge. And guess what, I like this challenge because you have to write some assembly. And let's go, we download the file, we have fun, okay, let's run it, give me code. And nothing. Okay, maybe more A's. Alright, we see the program segfaults, and let's see what we have. GDB fun, sec, and we see it has nothing, parcel rel, no canary, no NX, no pi, executable stack. So our goal right here is probably execute some syscalls like execve. And let's see, let's just run the program. B, C, DDD.
These nuts. Got him!
And okay, we see that it crashed at an invalid address 0x19904141. We never actually added some nopes here, but this is what we get. And we see that after every 2 bytes, 4141, it adds some nopes, 2 nopes, 4242, nope, 4242, nope, 4343, nope, etc. So as we can understand, after 2 bytes, the program adds 2 nope slides, 2 nope instructions, and our goal here is to construct some exploits, some execve with just 1 byte instructions. And how we're gonna do that, let's see, we go here, this is for 32-bit, the syscall table, and we see for execve what we need EAX to contain 0x0b, and EBX, the address of 𝗙𝗘𝗟𝗟𝗪, ECX null, EDX null, and this way we're gonna call execve. And let's go and craft our payload, slowly. Before that, this is what I told you right here from the syscall table. Also, we need the int 0x80. This is actually the similar to syscall in 64-bit binaries. This will actually do the syscall int 0x80. And a brief theory before we proceed. Let's say we have the register EAX and it contains 0x deadbeef. AL, for example, if you take the second letter of the register, A, and L, it just takes the lower byte, the lowest 8 bits, and AH, A and H, this will actually take the previous one, which is this, B. Same for other registers, for example, if it was EBX, it will be BL and BH. For ECX, it would be CL and CH, and okay, you get the point. And apart from that, what we need to know about the challenge is the shift left instruction. So let's say we have EBX containing this, 0x blah 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 DE. So if we do shift left EBX, it will actually, by 8 bits, it will move this DE from the last byte to the previous one. So 8-bit shift, it will actually move it here. If we did 16, it would be here, yada. And the last thing we have to know is the hex values of the string 𝗙𝗟𝗟𝗪 and the slash, which are these values. This will come in handy later. So let's go and start crafting some assembly. First of all, what we need to do is, first of all, clear registers. And I'm gonna clear EAX and EBX. I'm gonna use these two to push my string 𝗙𝗟𝗟𝗪 on the stack. And after that, I also gonna use ECX as my counter. So I'm gonna do something like move CL. If you remember, ECX, so we take the second letter, C, and the lowest byte, and we're gonna move 16 to that. I'm gonna do a 2-byte shift on the left. And after that, what we need to do is push bin_sh on the stack and start with sh. So these are our first 4 bytes we need to push on the stack. And let's see, first of all we're gonna do move bl, I'm gonna do al, I will start with eax first. So move al, what we need here, null byte, okay, we don't need to include that. So I'm gonna do with h, and h we see has the value 68, so 0x68. And this will actually give racks eax something like that. It's gonna be 0x000 and 68 because we write on the lowest byte. And after that we need to shift left eax and ecx, so we're gonna move it 16 bits on the left, so eax will become something like this. This is gonna be 0 and it's gonna be here and here. So this will actually move h right here. And after that we have another 2 bytes we want to use, and we're gonna do move al. So what is it again? Not al, let's do ah first. And here we have h, so right now we want s, 0x73, and this is gonna be 68 73 00. And after that move al, and we want the slash, so it's gonna be 0x2f, and this is gonna be 68 73 and then 2f. So we actually managed to push, not on the stack, inside eax register, this string, because it has null s, null h, s, and slash. And after that we're gonna do the same for bin. So right now we're gonna use another register. I'm gonna use bl. So the last byte right here, let's go bh. I wanna have n, so xe. So ebx is gonna be like 6e 00. And then I'm gonna have bl to be, this is n, so I 0x69, nice, right here. So I'm gonna have this, and then I'm gonna shift left, so ebx is gonna have 6e6900. So it's just moving left what we have written. And after that we only need to play with these 2 bytes, so we're gonna have move bh, and it's gonna be b 0x62, copy paste, oh my god. So ebx is gonna be 62 here, and this one should be the last one, bl, and ebx is gonna be this address with just 2f in the end, so like this. And now we have actually managed to push bin sh inside these 2 registers. So I'm gonna push that on the stack. How we're gonna do that? Push eax, push ebx, so this is actually on the stack, and then I'm gonna move ebx esp. So this one, this will push the string on the stack, and then this will move the string from stack in EBX, because if you remember, EBX here should contain the string 𝗙𝗪𝗧𝗖𝗛. And now what is left? Again, we need to clear the registers. Not this one. Right here, let's say ECX and EDX. And last but not least, syscall. So right here we have int 0x80, and this will hopefully give us cell. Let's see, Python solver. Fuck. So where did I go wrong? Oh, move al, and we want 0xb because we want EAX to contain this. We have set up EBX and the rest of the registers, so we only need EAX to contain this value. Fuck! Oh my god, how did I miss that? Yeah, that's the problem when you copy paste things. And we see that we actually managed to get cell locally. Let's also try that. Let's also try this remotely. And right here we have Python solver and ID, ls, and we see that we actually managed to get cell remotely as well. And that was the challenge, guys. I found it pretty nice. I like writing assembly. So if you liked the video and found it useful, leave a like and subscribe to the channel to support me. And see you on the next video. Have fun. Bye.